Hi Algebra 2 students. Today we're going to start graphing square root functions only. So let's take a look at this graph here on the left and what the parent function of the square root of x looks like. What I want to do is pick some values for x. So I'm going to pick 0, 1, 2, and 3. Easy numbers to work with. Notice that I didn't pick any negative numbers because I can't square root a negative. So when I plug in 0, I get the square root of 0, which is 0. When I plug in 1 for x, I get the square root of 1, which is 1. When I plug in 2, I get the square root of 2. When I plug in 3, I get the square root of 3. Those are hard y values to work with. So what if I pick something a little bit more friendly to work with? How about 4? Because when I square root 4, I get out 2. And what about another perfect square? How about if I pick x to be 9? When I square root 9, I get 3. So what I want to do here, and you're going to hear me say a whole bunch, is to pick smart choices. Smart choices for x are going to give me nice perfect squares underneath the radical. They make it easy to plot for my x and y. So I've got 0, 0, 1, 1. I'm going to plot 4, 2, and 9, 3. Again, easy, nice whole numbers to pick. And then I'm going to go ahead and connect the dots. And it looks like this. Again, notice here we have a stopping point at 0, 0. There's no graph to the left because if I try and square root a negative, I'm going to get no real solution. So this is the parent function of the square root of x. It has a basic kind of half moon shape, and that's it. So if we look at this, because down below we're going to talk domain and range. The domain of this function, well, we said I can only pick positive numbers because if I pick anything negative, I'll get a no real solution. So our domain here would be x is greater than or equal to 0 because that's the first x value that I picked. My range would be y is greater than or equal to 0. Notice that my first y value is 0, and from there, they're all positive. They go up. So now if we look down here on the left, if we talk about how we shift square root functions, this should look familiar with our h and k. Just like we did in our other functions, h lies and k tells the truth. What the h and k are going to tell you is what is that starting point. And what I mean is, like above, our starting point was 0, 0. We didn't have any graph to the left or below 0, 0. Now here it says pick x values that make perfect squares under the radical. Just like above, we picked 2 and 3, but they didn't make perfect squares, and so I picked x to be 4, x to be 9, to get nice clean numbers for my y values. We're going to sketch my graph, and then here, big deal, this is the first time we really see that our domain and range change. Okay, so our domain is going to be based off of h, and our range is going to be based off of k, and we'll see that in a minute in our next examples. So let's go ahead and turn the page. We're going to work through a few examples with shifting our square root functions. Okay, so let's take a look at number 1 on graphing square root functions. Here again we have our model, a times x minus h plus k. So the first thing we always want to do is identify that starting point, which is going to have a coordinate of hk. H always comes from underneath the radical. And remember, h lies. So since this is minus 1, h would be positive 1. K tells the truth, so 2. And that is going to be the first point on our square root function. Now I want to pick one or two more points for x that will make a perfect square under the radical. So a reminder, perfect squares are 1, 4, 9, and so on. After those few, we get off our coordinate plane. So how could I make a 1 underneath the radical? So think about it. Something minus 1 gives you 1. So the answer would be 2. Well, what if I wanted to be 4 under the radical? Something minus 1 gives you 4. And that would be 5. And then same thing for 9. Something minus 1 gives you 9, and that would be 10. So when I plug in those x values, I get nice clean numbers out of the radical. So I get the square root of 2 minus 1 plus 2 would be the square root of 1 plus 2. 1 plus 2 is 3. So I get a coordinate at 2, 3. If I plug in 5, 5 minus 1 is 4. Square root of 4 is 2. 2 plus 2 is 4. So 1, 2, 3, 4, 5, up 2, 3, 4. If I pick 10, 10 minus 1 is 9. Square root of 9 is 3. 3 plus 2 is 5. So at 10, 5. Now I'm ready to connect the dots. Again, notice here at 1, 2, nothing goes below it, nothing goes to the left because that is my starting point. Now let's look at the domain. The domain is based off of h, so x is greater than or equal to 1. The range is based off of k, so y is greater than or equal to 2. Again, these h and k values right here is where I got those. Alright. So, whoops. What was that? Sorry, my computer just glitched on me. Okay, let's try number 2. Same thing first. We're going to start by finding h and k. Remember, h is always the number underneath the radical. And notice that it's just x underneath the radical. So my h value would be 0. My k value is the number outside the radical, so my k value is -3. Okay, so now on to let's pick x values that make perfect squares under the radical. Well, notice it's just x. So perfect squares under the radical are no big deal. We can pick 1, 4, 9. So let's do the math. When I get -2 times the square root of 1 minus 3, make sure you do your order of operations. This is being multiplied first. So that would be -2 times 1 minus 3, or -5. Now I'm going to plug in 4. -2 times the square root of 4 minus 3 will give me -2 times 2 minus 3, or -7. And if I do the same thing for 9, square root of 9 is 3. -2 times 3 is -6. Minus 9, or excuse me, minus 3 is -9. So what do I have so far? Well, my HK, 0, -3, that is my starting point. From there, I have a point at 1, -5, at 4, -7, and 9, -9. Now, hopefully, the first thing you're noticing here is that these points are going down. Our half moon has flipped over. What do you think causes that? Yep, you're right. This negative right here causes that half moon to flip underneath, and that's exactly what your y values are showing. They're going down, down, down. Okay. Well, now how does that affect our domain? Remember, the domain is based off of h. Well, 0 is our first x value, and they all go to the right. So x is greater than or equal to 0. But what do our y values do? The y values start at -3, and then they go down, down, down. So y is less than or equal to -3. Anytime you have a negative a value, your range is going to turn into less than, because your y values are going to go in the negative direction. Okay? Okay, so on to number 3. What I would like you to do with 3 is I want you to try this one on your own. So go ahead and pause the video, do everything that you can on your own, and then come back and see how well you match up with me. So you should be paused. Alright, so hopefully you tried this one on your own, and I'm going to start with my h and my k value. Remember, h comes from underneath the radical, h lies, so it's +2, so h would be -2, k would be 1. There's my starting point right there. Now I need to pick some x values for underneath the radical that make perfect squares. I'm adding 2, so easy x values to pick would be 1, and then another easy x value would be, oh no, 1's not right. What am I thinking? How about 2? 2 makes better sense. And how about 7? If I pick 2, 2 plus 2 is 4, square root of 4 is 2, times 2 is 4, plus 1 is 5. If I pick 7, 7 plus 2 is 9, square root of 9 is 3, times 2 is 6, plus 1 is 7. So here are my points, 2, 5, and 7, 7, and it looks like this. So all that's left is to do our domain and range. Our a value is positive, that means our range is going to be greater than. So x is greater than or equal to -2. Y is greater than or equal to 1. Okay, so lastly for number 4, this is just written in a different way. We've been working on rewriting rational exponents in radical notation. So know this is the same as 3 square root of x minus 4. And I think you'll like it better in that form. So same thing that you did above on 3. I want you to pause the video, try it, and then catch up with me. Okay, so hopefully you gave this a try on your own. And I picked, for underneath my radical, I picked 5, because 5 minus 4 gives me 1. The square root of 1 is 1 times 3 is 3. I picked 8 because 8 minus 4 is 4, and then square root of 4 is 2 times 3 is 6. So today we are only working on square root functions. In your homework you have both square root and cube root graphing functions. I only want you to graph square roots. Only graph square roots in homework. Alright, thanks so much for watching my video.